Hello, this is JB Morin. I'm going to show you our tutorial for using the spreadsheet that we've designed with Dr. Pierre Samosino to calculate the jumping force velocity profile and to estimate the force velocity imbalance based on this profile. So if you want to read the theoretical basis and the publications around this approach, you have here access to online papers. These papers show first the validation of the equations that we are going to use against force plate measurements that was done in 2008. Then we explain in this paper and in this second paper the concept of optimal profile and the validity of this profile and the equations used to determine this profile. Then in this paper we show how it's related to performance, basically showing that everything being controlled, a difference between the actual profile of the athletes and the optimal profile as we calculate it is related to a lower than expected jumping performance. And in this paper, it's a commentary, it's a practical summary of the approach. You can read how to use this profile in monitoring your athletes and in better designing their training program according to their needs in terms of force and velocity for jumping. So let's go back to the spreadsheet itself. First, you will be able to enter some dates and some informations here, time or whatever. So let's say that's in the morning. Then you can have here the name of the athletes. So let's say that his name will be Joe Smith. Anyway. And here you will have to insert some anthropometrical data about the athlete. So his body mass, let's use 80 kilos. And then here the two measurements that you need to do beforehand are the lower limb length, which is measurement 1 here. So you will have to measure the full extension length from a mark that you will draw on the iliac crest, for example, and the tip of the toes in full extension. So that's basically the position that the athlete will have at takeoff. So let's say that this athlete has a 1.12 meters full limb extension length. Then the second measurement that you need to enter is the initial 8, which is the 8 of this iliac crest mark in the starting position. So the starting position should be comfortable position with the heel to toe on the ground, stable and ready to push and jump for maximum 8. So it should be with the knees around 90 degrees, but if it's not exactly 90 degrees, but the athlete feels comfortable, then you use that 8 and you enter it here. So let's say that we have a 0.8 starting 8. The spreadsheet will calculate what we call the push-off distance, which is HPO. The push-off distance is basically the distance on which your legs will extend during the push-off. And it's very, very important that for every trial, the starting 8 is respected and the starting 8 is checked quickly, visually, or using a ruler or a stick or whatever, because the starting 8 influences HPO and HPO influences every mechanical output afterwards. So now that everything is done here, you have to decide how many loads you will use, and then you have to enter the additional loads and then to enter the jump weight at each of the 1, 2, or 3 trials that you will use. First of all, remember that in order for the test to be accurate, subjects should be familiar with jumping with loads on the shoulder, having a stable, clear push-off with the limb extended, and having a stable, clear landing with the exact same position. So no trunk movement, no counter movement before pushing, no knee flexion, and feet fully extended at landing as they were at takeoff, because the computations are based on this. So now that you have selected your loads, you can put the list here. Let's say 0, 20, 40, 60, and 80 kilos. That's going to be my test. Of course, you can jump with the loads in the randomized order, but in my spreadsheet, it's going to be this order, okay? And then you do trials. Our advice is that you should do at least 2 trials, but if the athletes are reproducible and there's no variability in their trials, you can choose to do only 1. but the spreadsheet will select the best trial here and calculate things from this best trial if you decide to have more than one trial. So let's say that I do my testing and I enter the jump height in meters here. So the first jump is a squat jump, in fact, so that's 33.1 centimeters. The jump with 20 kilos gave me a jump height of 0.267. When I used 40 kilos, I was 0.212. When I used 60, I was 0.18, which is 18 centimeters. And my heaviest load gave a jump height of 0.137. Please note that if the jump height with the heaviest load is higher than 10, 15 centimeters, then you should try an even heavier load in order to have a spread out load conditions. So as you can see here, my FV relationship is almost linear, which is here shown by the very high R square. And if something happens and a jump height is too high or there has been a counter movement or whatever, you will immediately see that one of the conditions will be out of the line. So you have two possibilities here. Either you retest because something was wrong in the technique, or you can decide to remove that condition by removing the entire line of data here and calculate the FV profile on 4 loads only. So this is an important issue. Of course, as you know, you can have a linear profile with only 2 loads, which is the case here, 0 and 80. But in my opinion, you should use at least 3 loads to calculate the profile, because as you can see here, the data that you have with 3 loads are about the same as the data that you have with 5 loads, of course with my 0.80 jump here. Okay, so basically 5 is very accurate and good, 3 is okay, 2 in my opinion will lead to some variability, although some studies showed that statistically the relationship is not different between 2 loads and more loads. So now the data that you have are here. This is the main block of data. First, F0, which is the maximum theoretical force in the context of jumping, that's this point here. Then V0, which is the theoretical maximum velocity of limb extension. The maximum power here, so please remember that all these values have been validated against force plates data, so you can trust them. And here SFV is the slope of the FV profile, which is the orientation of the individual profile. Then you have 2 more informations here. The blue line here shows you the optimal profile that we calculate according to this publication. And the optimal profile in blue tells you the profile that would allow for the maximum jump height in this individual. And as you can see here, there's a 17% difference, so that's what we call the imbalance between the actual profile of the athlete and the optimal profile for jump height. So the idea then is to orient training towards improving that V side of the curve and shifting this profile towards the optimum. Then the pink block here shows you an optimal profile condition and the associated imbalance, of course, for a 30 degrees push-off, which corresponds to roughly a sprint start or a swimming sprint start. And as you can see here, the optimal profile depends on the angle of push. And so if you want to optimize a 30 degrees push-off, then you have to work a bit differently. So if you want to connect on how to design a training content to reorient the profile, you can read these papers, and especially this one published in 2016. The download link is here. And then you can monitor your athletes and reproduce this test as frequently as you wish. All right, so the final step here is that to measure jump height, you can use any available valid and accurate device. So this includes force plates, of course. This includes linear transducers, jumping mats, opto jump, or the fancy and accurate iPhone and iPad applications, My Jump by Carlos Balsalobre, and you can use this spreadsheet as a support to calculate everything. So here we go. Enjoy the FV profiling, and see you soon.